Welcome to the next presentation. Clean PowerNet Partner Report means we see now two different young men within this presentation. The EN500P SOFC fuel cell system for different markets, presented by Dr. Matthias Boltze, CAO of new enerday GmbH. You can find him at booth C30. Autonomous fuel cells, PV-Wind-Ely-Battery energy supply in the EnerSta project, presented by Groos from the Fraunhofer-Institut für Solare Energiesysteme ESE. He can be found in C58 directly at the Fraunhofer booth. The presentation will start.
Yes, hello. Good afternoon, ladies and gentlemen. I'd like to introduce my company, New Energy. It's a company in northern Germany. We are dealing with SOFC, high-temperature fuel cell systems operating on logistic hydrocarbon fuels. And we are part of an energy and industry network, the Clean Power Net, a German industry network that are dealing with autark energy solutions. A short introduction of the company. It was founded in 2010 as an independent company from a former 8 years big development program at the German automotive supplier Webasto, dealing with SOFC components. We are focusing on system module powers of between 350 to 750 watt, and we operating on logistic conventional hydrocarbon fuels like propane, natural gas, bioethanol, or later on diesel. This diesel know-how we have from the Webasto development, and another specialty of these systems is that they are apply no water, no inside or no auxiliary water. That means you have no problems with freezing. The system has cold start abilities, and I think this is a USP for fuel cell systems itself. The systems are very robust. We showed more than 500 hours maintenance-free operation, a benefit for the customer, and we think we have the world's most efficient energy converter for hydrocarbon liquid fuels with net electric efficiencies of more than 30%. We are talking about hybrid system. I come back to this at the end, and our target markets are in general off-grid power or backup power. Everywhere where you have no power, you can apply our systems. Why we use logistic fuels rather than hydrogen? The answer is, of course, the energy density of liquid fuels is much higher than, for instance, of hydrogen. You can see here both the comparison. Same energy content is in this 1 ton hydrogen store and in this 59 kilogram propane bottle, and introduce this or compare this to lithium ion is half a ton or 5 ton lead acid batteries. LPG is a worldwide logistic fuel. That's why it's a perfect fuel for autarkic or off-grid power solutions. You can see some pictures that this propane is worldwide available, and that's a good news because then our system can operate in whole the world. A typical installation, in any cases we talk about hybrid fuel cell battery hybrid system. This means from the fuel we come via the fuel cell to charge a battery. That means we have a buffer, an energy buffer to supply more power than the fuel cell itself can give at continuous operation. A typical operational time for our system is maybe for applications like this leisure applications or off-grid power with an operational time of 5 to 10 weeks a year. This is typical for all these applications. I will show you examples of real installations to give you some numbers of experience in testing systems. Our longest real running system was more than 4,000 operational hours with less than 5% power degradation. Right now we tested since mid 2011 more than 45,000 hours summarized, and consumed or converted more than 4.5 tons of propane, generating more than 16 megawatt. In our test experience, we test systems in climate chambers, and this is the difference of our system. We have no water inside, no freezing. We can start up the system from up to minus 20. We right now in the climate chamber again to go down to minus 30, minus 40, and especially in cold application. This is a benefit compared to, for instance, PEM systems with water management. We also test systems for robustness on a shaker. You can see a running system tested on a 8 hours very hard shaker program. System operates well, no problems at all, and that shows that the technology is not fragile because we have ceramic components integrated in the SOFC stacks. But it's a real robust technology. Our products, we have a modular strategy to integrate not only one single module, but we can integrate more than up to 3 modules in such an industrial applications together with batteries and power electronics to give a real UPS system that starts quite when the grid fails. Comparison to different other energy converters over all technologies that are possible: diesel generators, direct methanol systems, other PEM, propane systems. In terms of fuel consumption or specific fuel consumption or specific energy cost, our systems give in all cases more than 30% net electric efficiency, and we claim to be the world's most efficient energy converter for liquid hydrocarbon fuel in that. Some installations, real installations, the system can operate on propane and natural gas too, both without any changes. You see on the left hand side an outdoor installation of a system, 500 watt system at a local gas supplier in northern Germany near our company, running on natural gas, and on the right a test system on a market partner in southern Germany running on propane. This means fuel flexibility and also an advantage for the customer. Another picture from this outdoor operation system. We operate this right now for 2,500 hours. Start the test beginning of December last year. It was rather cold outside there, minus 18 Celsius. System operates 24/7 without any problems. You can see the snow on the system. No problem at all. The outdoor ready housing. Okay, another interesting installations on a houseboat. Is a private-owned houseboat here with 2 big liquid propane tanks. The installation in front of the system, the owner of the houseboat, and we also filling up with a local gas supplier the tanks. Once a season, and then he is able to operate the system whole season on his houseboat and is completely autark from any net supply. And final, we have on booth 30 a running system. You can see a 500 watt running system over there, operating on such a traffic trailer, supplying this display. You can see here the fuel cell. You can see the gas bottles, 4 gas bottles with in total 20 kilograms of propane, and the system is able to operate with this installation 1 month completely autark. Okay, so I'm at the end of my presentation, and maybe you have some questions to this. In other case, my colleague Ulf Groos from ESA will take over for the second part of the presentation.
Yeah. Thank you very much for this informative and interesting presentation here, and it's very short, it's fine. Thank you very much for this. So, are here any questions quite around? Just raise your hand, I come to you with a microphone. So, not yet. I think you're a little bit here at the booth, and in another case, here you are on the booth here at the group exhibit. It's C30. Yeah, so you can visit Mr. Boltze over there. Okay, thank you very much. So then we continue our program directly with a presentation von Ulf Groos from Fraunhofer-Institut für Solare Energiesysteme. And the title of the presentation is Autonomous Fuel Cells PV-Wind-Ely-Battery Energy Supply in the EnerSta project. Thank you very much, and give him a big hand, please.
Thank you very much, Mrs. Lasner. So we are I'm waiting for my presentation, but if you like, I can also talk about protomotors development, but I guess they do it better than me. Okay, that looks like me. So my name is Ulf Groos. I'm from the Fraunhofer ISE. We are in the very south of Germany in Freiburg. And we did development for a fuel cell system for an autonomous power supply. This is integrated into a French-German project. The application is a telecommunication system for a special application. So this project is led by Airbus Defence and Space, former Cassidian. And the idea is to power this telecommunication station all over the year 24/7 by wind and solar. We do that by providing the energy to the application, of course, but also when we have excess energy, we store this energy into a battery. And if the battery is fully charged and we have still excess energy, we use it to produce hydrogen, and the hydrogen is converted into electrical power again by a fuel cell. You see here all of our partners. So for the battery, we cooperate with the company Saft in France, and then we have a lot of partners which you can also visit here at the trade fair. So we have for the electrolyzer CETH2 company in booth C57, and we store the hydrogen into a tank from Mahitech. You can visit Mahitech at B51. And a partner for the telecommunication housing is B+W, which is also a partner in the Clean Power Net. And we are responsible for the fuel cell system over here, and our booth is this direction, C58. And we cooperate with the German company Protomotors, which delivers the fuel cell stack, and Protomotor is also at the trade fair. Okay, so this is the site for the first prototype, and you can see it may be difficult to power a telecommunication all over the year 24/7, and this for 20 years. So we need a good idea for an energy and power storage. As you see here, no wind, no sun, so we need hydrogen for a larger energy storage. Our job from the Fraunhofer ISE is to develop a fuel cell system with very, very high netto efficiency. We decided to go for a PEM fuel cell, so the idea was a little bit other than Mr. Boltze from New Enerday presented. We use hydrogen as a energy transfer carrier, energy carrier, and so we decided for a stack from Photomotor. And yeah, we designed the system for net power of 1.5 kilowatt electricity, which is enough to power the station and to recharge the battery. It's a liquid-cooled PEM fuel stack with a closed cathode, which is for us very interesting because we operate worldwide, so we need to reduce the throughput of air to a minimum, because in the surrounding air there could be dust, there could be several pollutants that could harm the fuel cell stack. We need to have a high reliability over 20 years. You can see the system which we designed at our booth, so you can have a closer look to it. Here I just wanted to mention that we put a lot of effort into the development to realize a high efficiency. So in comparison to a conventional system, we reduced the energy losses from the peripheral system, which we did by a jet pump, which we integrated into the anode recirculation. The system itself can be integrated into a typical 19 Zoll rack, and we designed the fuel cell for a wide temperature range from -15 degrees Celsius to +50 degrees Celsius. If you integrate the fuel cell itself into the housing of the telecommunication system, you wouldn't need this cold start ability. But as a fuel cell always is an open system, it would be nice to not to integrate it into the hermetical closed housing of the telecommunication, and to go outside with the fuel cell outside of the housing. So then this wide temperature range would be needed. We realized the system by let's say two components or two modules. We have the fuel cell module on one side, and I showed the picture right before, and you can have a look at this. And then we have another, let's call it control module, where the DC-DC converters are installed and the control electronics. Yeah, the fuel cell itself is packaged with a technology from the also well-known fuel cell or well-known company also with fuel cells. It's called DMT, and they have this technique to integrate the components into a foam, which makes it easy to mount and assembly systems. You don't need any screws to fix the peripheral components. Okay, as the system is designed to be operated worldwide, we can operate the fuel cell and monitor the fuel cell via internet. and we can adjust the control parameters also via internet because we use a data base which can be changed remotely. Our task at the Fraunhofer-Institut is to give research and development services, and therefore we have a good infrastructure to test fuel cells. And this we did with our own developed systems. So you see our climate chamber where we tested the fuel cell system under different and also, of course, extreme climate conditions regarding the relative humidity on one side and regarding the temperatures itself. You see a large black box over here, and this black box has 50 channels available, and so we can contact each cell of our 48 cell fuel cell stack and monitor not only the single cell voltage but also the single cell impedance spectra in parallel, which is, as far as I know, unique in combination with the climate chamber. And this technology, and also to control the different peripheral components, allowed us to optimize the fuel cell system control. So we know at each temperature, at each climate condition, the exact fuel cell behavior, and can adjust the fuel cell control in that way that the fuel cell itself feels very comfortable, regardless of minus 15 degrees Celsius in the surrounding. Okay, and to show this behavior, I show you on the left the start behavior of the fuel cell, and you see that the temperature difference between inlet and outlet of the fuel cell is very close together, which means that we do not have any great inhomogeneities, but a very homogeneous behavior even under startup conditions. And in the graph on the right side of this slide, you see that also the, let's call it long-term behavior, it's only 4 hours, but you see a very, very stable behavior over time, also at very high temperatures, at plus 40 degrees Celsius, and a very low relative humidity. So even under this, let's call it extreme conditions for PEM fuel cell, you see a very stable behavior of the fuel cell system. Yeah, and that's as a very rough overview about our development, and yeah, I would be glad to answer some questions. Thank you very much.